So sorry for the bad connection.
That's fine.
My friend once said, and that's hilarious. He once said that imagine that oil rig as a new 2022 Mercedes Benz and deal with it that way. And that was hell of advice. You see?
That's a
Yeah,
good way to look at it. Trust me, don't
fake it,
expect a Mercedes
fake
Benz
it
over
until
there,
we
okay?
make it. Yeah, yeah, some kind.
If you won't expect a Mercedes Benz sitting at the rig side, trust me. For sure. Mercedes Benz does not get your hands dirty and your clothes dirty.
Actually, any kind of work that gets you dirty is an honest job. So
That's
I
a good
don't
point.
think it's a problem. Yeah, that's the point.
Okay. So that's a good way to look at it. Yeah. So you see, I mean, I don't think anyone. I mean, I never since my childhood I never imagined to be a petroleum engineer or drilling engineer. I mean, I wanted to be an astronaut. Then it turned out like, oh, you have to study a lot. Okay, I cannot be an astronaut then.
Here
Um,
comes the Elon Musk of India.
so see, I think passion and liking something is something that changes and grows as you are going forward. As you are learning new things in life, you would start discovering your passion as you go. Right now, I'm working with Landmark Halliburton. I'm based in Dallas. I I'm not going to the site anymore. I used to go to the drill site. I'm not going to site anymore. I am working as a product owner for developing cloud-based solutions. So now I'm not just keeping myself updated with the latest drilling technology, but also trying to stay updated with the cloud technology. What is cloud? How do you deliver a product on the cloud? How does it work? So I'm trying to learn that, and I'm not being a developer, but I did develop even a couple of things with Landmark staying here. I was writing few Python codes. I did that. I'm not saying I'm best developer Landmark. I'm not even working as a developer with them. But as you move forward, don't be afraid to try something new, and expertise will come as you keep going on. Don't don't think that you will only like something if you are an expert in that. That's not how it works.
Yeah, that's not the
Uh,
case.
yeah, try to find what intrigues you in there, and if it's something, even if it could be the smallest thing in that particular field, like your friend said, just imagine that to be the latest Mercedes Benz. That's fine. If that helps you, that's perfect thing to do. So there's nothing wrong in that.
Yeah, thank you. Such helpful advice. And you see, how do you see the future of oil and gas industry? Would it be more thriving and more exciting for our new generation? Would it be like we're getting a lot of jobs, a lot of money, and that's the most important aspect?
Okay, as far as future goes, oil and gas is not going anywhere. We cannot, like, it's just not going anywhere. The usage may drop down because now slowly oil and gas, we're not using the terms oil and gas anymore. We are slowly expanding into the terms of saying energy. It's not just oil and gas anymore. Uh, my suggestion, rather than what my comment, my suggestion to all of you is start your thought process from oil and gas point of view, but try to keep an eye also on the overall energy sector, where it's going forward. Because this is just my opinion, and I'm saying this out loud, but this is only my thought process here, that it to sustain with what we're experiencing right now, the climate change and the global political scenario for energy, it will be very hard for just oil and gas to sustain the overall energy needs. That will not be possible. Oil and gas alone cannot do it. There has to be a combined effort from all the other sources of energy that we have, and we have to start consuming them more efficiently. Uh, I like the word they use nowadays from the climate change point of view, the net zero. Nobody is saying that you reduce the carbon footprint of oil and gas to zero. No, that's not possible. You cannot do that. Your overall a contribution of CO2 footprint should be zero. The net should be zero, not just from oil and gas. So this is my advice to you guys. Start exploring in other directions. You don't need to start learning about solar panels and how do they work or batteries, but start to think in the way that whatever you are learning
Mr.
here.
Aman,
Yeah.
Mr. Aman, sorry for interruption, but it's 8
Oh,
p.m.
8
now.
p.m.
We
Okay,
should
let's start
start
with
the
that.
session.
Okay,
I'm so
okay.
sorry.
Yeah,
Yeah,
we
no,
shall
that's totally
start.
You can go ahead right now.
We shall start.
Okay,
So,
yeah, let's start that.
good afternoon, good evening, good morning, depends on where you are living. To all of the engineers, workers, students, and the respected principal, I greet you all to our today's lecture holding the title of Shoe Test. And for those who are new to our Full of Knowledge online courses, it gives me an immense pleasure to welcome you all to our SPE student chapter. Our chief guest, Mr. Aman Sarvastiv, one of the most esteemed personalities in the oil and gas industry, to talk about the guy, his story. That was a great story about the oil and gas industry thriving towards the top I've ever heard. And we thank him for sharing his story because this man's achievements are endless. Without further ado, I'd like to get into the expertise of Mr. Amans. Mr. Amans has a Bachelor Technology degree in Mechanical Engineering and National Institute of Technology. And also has a Master of Science in Petroleum Engineering from USA, I suppose, Oklahoma. More than 13 years of experience in the oil and gas industry, managing drilling, completion, and rig operations, cost optimization, field development, and reservoir management. Holds many patents in USA for rotary internal combustion engines, butterfly engine, real-time dull bit, grading, modeling, and process technique. Received many awards in SPE drilling and completion, 2019 Technical Reviewer Awards, the Way Ahead Outstanding Editor 2020, and other awards. Thank you, Mr. Amans. You're free to go.
All right. Thank you. Thank you for that introduction. I really appreciate that. I'm going to start sharing my screen here. So please pardon me if I'm a little clumsy because I'm not much user of multiple participants can share simultaneously. One participant. So I'm going to share my screen here and screen number 2. All right. Let me know if you can see my screen.
Indeed, we can see it.
Okay. Awesome. So thank you again for that introduction. Really humbling to see myself over there. Now I'm going to keep this a little bit open-ended. This is not a closed lecture session, so if you have any questions, just feel free to ask it. You can stop me at any point of time. That's totally fine. I can see the list right there. I think if you raise a hand, I would know, but I'm not really sure. So if you have a question, just ask me at any point of time. That's fine, and we can have a Q&A session afterwards also. Okay, so casing shoe test. The way I'm going to do this entire thing today may take like 30-40 minutes, I think. And I will be, I have slides here. I'll be going over this agenda, but I don't really care about the agenda because I'll be walking you through how we do a shoe test and what is the reason, what are the things involved in it. And I'll be doodling along as I go on. So I would be doodling on the slide and I will be doodling on one of my OneNotes as well. So let's start with this. Casing shoe test. Now assume that you guys have been having this series of lectures where you must already be familiar with cementing and casing terms that we are using. Now, what is a shoe test? Before we go toward the shoe test, we first need to understand what is shoe and why do we test and what is a shoe test. So what is a shoe? Now, here is the casing shoe, what you see on the left-hand side. Then what's the point of having this? I mean, if you are told to lower an open-ended drill pipe into a hole, so if you drilled a hole like this, oops, sorry, if you drilled a hole like this, you lower a drill pipe, that's totally fine. You can run it open-ended and you can have threads at the bottom and nobody cares. But why do we add this casing shoe at the bottom? So there are mainly two reasons why we do this. Number one is this has an NRV at the bottom. Sorry, I'll write it here. NRV, that means non-return valve. So it allows you to flow anything into the casing and outwards into the open hole, but it would not allow you to pump it backwards. So that's the first reason of why you have this casing shoe. The second is you can see this is a rounded bottom. Now, whenever you drill a hole, you might be drilling a hole, let's say 17.5 inch, and the casing you lower is a 13.38 inch casing, which is quite big. So if you have such a big steel pipe going in, which is extremely stiff in nature, it is very likely that these threads or the end of this pipe may get lodged on the side or on the hole, on the open hole that you have drilled. So that's why we put a casing shoe at the bottom, which is rounded in nature, which kind of guides your entire casing all the way to the bottom. So if there are tiny ledges or bumps, you just smother through it. It slides to the entire hole. Now you have this rounded thing right here, and you have an NRV right here. Now there is another float collar as well. We put up here. We call it a float collar, which is shown right here. And it also has an NRV in it. And the one or two casing joints between your casing shoe and the float collar are called as shoe track. So if I draw, let me move here. This is much better now. So if I draw a casing string, you will have a casing shoe at the bottom, and then you will have a float collar, one or two joints above. And this part is called as shoe track. This is the float collar. This is the casing shoe. Now, when you lower this casing shoe into the hole, what it will do is actually let's say I'm going to draw a hole, and I'm going to draw a vertical hole just for simplicity's sake. We take a casing, we come down all the way to here. This is the shoe. Oops. All right, so we have drilled till this depth, and we are like 1 or 2 feet above the bottom, and we have this thing right here. Now, as soon as I reach the bottom, I'm going to start circulating so that I am sure that the mud is conditioned before I cement it. For cementation, I think that it is part of a series. If I'm not wrong, I saw that you guys will be using, you guys have lectures on how primary cementation happens. But anyway, we drop plugs and the cement is filled in the shoe track and in the entire open hole till whatever depth we want. So it could be to the top of surface, could be all the way to the surface, or it could be till any isolating any zone of interest that you want. Or if you have a previous casing, right before that, if you have a casing, you can actually cement only to that casing level. You don't need to bring it to the surface. Well, that's fine. We are talking about shoe track here. So I have my casing in the hole. My casing has been cemented. Now, why do I need to test this shoe? What's the point of testing this shoe? Now I know this is the shoe, but what's the point? The point is that I'm going to start drilling out this entire thing. So if I take an eraser and I start drilling, I drill out the float collar. Now these all things are drillable. So what you saw in this slideshow, these two, like obviously not this metal part, but you can drive a drill bit through this entire float collar and this entire shoe. These are usually made of cement and a little bit reinforced cement and plastics. And you can even see them when they come on the surface. You can see big pieces of plastics coming on the surface, and these are drillable materials. So you can drill them with just a regular bit. So we're going to drill out this shoe, and we're going to drill out this part. Now my entire casing is open, and this part now, which is right at the communication of the casing and this last formation that I drilled, is called as shoe. Now my new hole is smaller in size. Obviously, it's smaller in size like this. So this will continue to be called as a shoe. And every time somebody says, you will hear this term very common used in drilling industry, and whenever you guys will work as drilling engineers, okay, are we above the shoe? Above the shoe means, is your drill bit inside this shoe, which means your drill bit is inside the casing. Because this is a casing, nothing will happen. It's a solid steel pipe, so nothing will happen. You can keep it there for days, no damage done, you won't get stuck. But if you leave it here, you can get stuck. So why is this shoe such an important thing? One of the simplest way to understand this is, as you are drilling deeper into the formations, you have several layers of formations, you're drilling down and down. As you're increasing your depth, it's very safe to assume that the formation hardness is increasing, right? As you're going down, the formation is getting harder and harder because of the overburden right there, and there's a lot of compaction happening. So obviously it means that as I'm drilling down, if I ask you, all right, this is a steel pipe, so there's nothing going to happen over here. But in this entire green part, which is the least hard, or the least, the formation with the least compression strength, and that would be the topmost part here. And of course, it also has a cement, which, you're kind of like creating a bond between the cement and the formation. So this kind of becomes your weakest link. If there is any gas that channels from here into the cement right up here, it can start traveling up really fast, or it can start damaging the formation here, or it can even start damaging the casing. If there is any rupture in the casing, any damage in the casing, any wear in the casing, you will start seeing the damage, that gas or any oil leak coming up here. So this casing shoe part becomes your weakest link in your entire open hole section. Until you cover it up completely with another joint of casing, this will continue to be your point, your weakest point. Yes, there's a question thing. I saw a hand raised.
Mr. Aman, you can keep going. There's no
Okay.
any raised hand.
Okay, that's fine. All right. Okay, cool. If there's any question, please stop me in the middle. That's totally fine by me. All right. So we see a weakest link. Now we know what the weakest link is. Now, if you have a weakest link, you have already cemented that. So there's nothing more you can do about it. So let's test it out. Let's ensure that this weakest link is strong enough to hold us till we reach our next target depth, till we reach, if I can zoom out a little bit, and if I draw this, till I reach this target depth, finish this up, and lower another joint. Oops, sorry, that was very bad. Okay. Till I lower another joint of casing all the way to the bottom, and with the casing shoe at the bottom again, and cement it all the way to the top. Now I'm safe. Now I know that this is no longer the weakest link. The weakest link now becomes something else. So it will be the bottom part. So that is why it is important for us to test the shoe. Now the question comes in, what is a shoe test? So let's get to that question. What is a shoe test? Now, what I'm showing you here, and I can share this slide with you. That's not a problem for me. I'm showing you here literally the steps we take. How do you conduct a shoe test? This is like step-by-step process we do at the rig site. How do we do it? And before I come to the question, why do we do the shoe test? I wanted to cover this part on how do you conduct a shoe test, so that we can come to the part later on, and you can see why I did this. So if you're at the rig site and you get an order that, okay, guys, we're going to conduct a shoe test. So there are some pre-test preparations you have to do, and these things should be very clear to the drilling engineer or the rig site supervisor or the company man or the tool pusher, whoever, whatever role any of you is playing. You should be very clear on number one, what is the test plan strategy? What are we going to test? Is it an FIT? Is it an LOT? What kind of test are we conducting? And I'll come to those points right after the slide, so don't worry about it. So ensure the test plan strategy is very solid before you even start with the test. ensure a blank P and V chart is available. Now, this could be something that you may not need, because nowadays any unit that you use, you have computers, they can plot everything for you, immediately. So that's not required. But you know what? A pen and paper is much more stronger than any computer in the world. So you make sure that you have a pen and paper in your hand, you're drawing the chart, you have a blank, you have a very clear idea how you're going to draw the line. And I'll also come to the part why you need this PNV chart with you earlier, or talk to the computer guy if he can do it for you instantly. Ensure all safety points are available for PJSM. PJSM means pre-job safety meeting. This is very important because when you are doing a shoe test, it's a pressurized test, and pressure means danger. So we need to be very clear on what are the safety points, where it can leak, if it leaks, what we're going to do, who's going to operate the pump, who's going to stand where. It should be very clear to everyone. So all the safety points should be available to the PJSM. So how you're going to do the shoe test? Well, it's actually quite easy. So like I told you, we have drilled this, we lowered the casing, we drilled the shoe, and we drilled a new hole. So this is a new hole we drilled, but we drilled only 15 feet, 10 to 15 feet, depending on whatever you want to do. So 15 feet, that's all you drill. So in meters, it's almost like 5 meters. That's all you drill. As soon as you drill till here, you pull up your bit till this point. So your bit is now inside the shoe. Like I said, it's now inside the shoe. This formation is now opened up. So you have 15 feet of formation, fresh formation opened up. Now you're going to circulate the hole clean and ensure you have consistent mud weight. Everything is good. You pull back inside the shoe, connect the relevant controlled pumping line or rig line or cementing line. Usually you would want to do a cement casing shoe test, or sorry, shoe test with a cementing unit. It's because they have a very precise pump, and they can pump very small volumes in very controlled quantities, and they have very good pressure gauges. They can do that very precisely. Rig pumps are usually bigger in size, so it may be a little clumsy to use them. But doesn't matter. It depends on what you have available over there at that point of time. So you connect the relevant control lines. It is essential to keep in mind if the drill string has a float sub. Now, this may not be relevant right now, but if your drill string has a float sub, you have to keep that in mind, because the pressure may not bleed if there's a float sub. You have to make sure they have bled off all the pressure. Anyway, circulate again with the control pumping line to ensure no air. So if you have, so let's say this was your well that you drilled, and on the surface, you connected a pumping line. Now, earlier you had circulated and showed no air is in here, but you have to make sure there is no air here as well. Now, why bleeding off all the air is important? Why is making sure there is no air in the system so important? It is because air is compressible. Air is extremely compressible. Actually, all fluids are compressible, but air is extremely compressible as compared to the drilling fluid that you are using. So if you have an air bubble, it will start getting compressed and you would not get a good result. So it's very important to know that there's no air in the system, but this is something that depends on the line arrangement and how you have positioned it. So the pumps can sometimes control if there is any air or not. You do a PJSM, like I said, pre-job safety meeting. At this point of time, you tell everyone what you're going to do. You ensure there is no flow. The well is not under self flow. You're not getting a kick, and you're not losing any fluid. The well is completely stable. You close the BOP. This is extremely important. You had a well, you are going to close the BOP. So now you have shut down the BOP. The well is completely shut in. And now you start pumping at a very low pumping rate, very small pumping rate. And with each volume pumped, note the pressure. So again, like I said, you have a chart available with you. You were at 0.0. You pumped, say, what we say, 0.1 barrels. You got some pressure. 0.2 barrels, you got some pressure. 0.3 barrels, you got some pressure. 0.4 barrels, you got some pressure. You keep on plotting that, and ensure that you are, you're plotting this POV chart as you are pumping. You don't need, you cannot wait for the test to get over and then plot this. It has to go on simultaneously. Once you keep plotting the PV chart, you keep pumping, and once you have reached the success point where you say, okay, my test is done, you're going to bleed back the return, bleed back the entire pressure and check the return volume. This is extremely important. I want to come to you why this is so important thing. You have to check how much volume of fluid comes back to you. You open the BOP and then you check for flow and loss. You resume your operations. Easy peasy. I know there's a lot of steps here, but actually all you're doing is you shut in the well, you pump some fluid into it, and you note down the P and V plot. You stop pumping, you bleed back, you start your drilling process. It's usually very smooth. It's usually very easy to do. Now, why are we doing this? Now the question comes in, you know how to do it, but the question comes, why did I do all these steps? So if you are on the rig side and you are plotting pressure versus volume, so you have volume right here and pressure right here. If you're plotting these two as you are pumping, like I said, you will start from 0, 0, and you will start plotting this line as you're going up. Now, look at this line. It's perfectly straight going up. Right now, what is happening is you are doing a limit test. Some people call it limit test, or actually you are performing an FIT. FIT means formation integrity test. Because what is happening is whatever you pumped, the formation is able to, the volume that you pump, the formation increases, it holds that volume, and the pressure starts increasing in the entire system, in the entire wellbore. So you are getting a formation integrity. What is the integrity of a formation? How strong it can hold that pressure. It could be 200, 300, 400, 500 PSI. And that is where the formation strength is holding up for you. At one point of time, there will be a point of time, if you keep on pumping, there will be a point of time where it will start deviating. So this was supposed to be a straight line, which would have continued, but then you started deviating. This is the leak off test. And unless you are plotting live, unless you are plotting as you are pumping, you would never know when you reached LOT because you would just keep on pumping. So you need, that's why I told you it is very important to keep a PNV chart in front of you or keep looking at the computer screen to ensure at what point of time you deviated from that straight line. So right here, we deviated from the straight line. This is the LOT point, leak off test. This is the part, if you look at it, what is happening is this was a straight line earlier. So your pressure versus volume was completely in a perfect slope. But now that slope has changed. It is able to drink more volume of fluid than it is increasing the pressure. So the pressure increase actually is not that much as compared to the volume it's drinking. So it's actually drinking right now. And if you keep doing that, you're going to come to a part which is called as FBP, which is formation breakdown pressure. You are going to break down that entire formation, which means fracture is going to open up. Don't do that. Well, if it's told, you're told to do that, that's a different point of view. But it's a very common scenario that you don't reach the formation breakdown pressure during an LOT test and FIT test, because then it can lead to much more complications. It will prevent you from drilling ahead. You will have to do some more remedial jobs on it. So you can see what is happening here. As soon as you reached FBP, it just drops down. The pressure drops down because all it did was it drank a small amount of volume and the pressure completely went down. You have opened up a fracture and the fracture is now propagating. It's drinking more and more fluid. I'm increasing the volume, but the pressure is not increasing. It's just going up and down slightly. And you started to fracture the entire formation. Now you come to a point which is FPP, which is a fracture propagation pressure, where from this point onwards, your fracture propagation has started, and then you reach an ISIP, which is actually a term for the friction pressure, and FCP, which is fracture closure pressure. Now, this part, I would say, I'm not going to cover in this lecture. This is all I want to say about this part. The reason being, if you have a professor who is proficient in hydraulic fracturing or geomechanics or rock mechanics, please ask them. They're going to explain this to you beautifully, how this thing works. Why is it so important? Why do we want to go to this point? And how will you go? Because I just told you, as a drilling engineer, I would never want to go to this point. I'm drilling right now. I'm, in my intermediate casing, I still have to drill the production. So I would never want to go and start leaking and start propagating a fracture. Why would I want to do that? But everyone is interested to know this. This is a very crucial formation property. There are correlations available. So speak to a professor, look into books, go to libraries, read some papers. This is very interesting part, hydraulic fracturing. This is all how we fracture the formation, acid fracturing, hydraulic fracturing. This is the realm where they will play. If you all get to be production engineers or fracture engineers, this is the part you will be focused on. Anyway, I'll come back here. So we have an FIT going on, we have an LOT going on, and we stop at LOT. Leak off test, as soon as it deviates, you maybe want to go a little bit more so that you ensure that you have deviated away indeed, and that's it. This point where you deviated away from the straight line is the leak off test. You stop right there. Now, why did we do it? What's the point? Now, I'm going to cover what's the point along with the company practices. So what's the point of doing this shoe test? Now, whenever you are, when you are a drilling engineer, this is, and you're designing a well, this is a question you're going to ask yourself, your boss, your peers, reservoir engineer, geologist. Why are we doing this shoe test? The reason we are doing shoe test is we want to know about the frac and the formation. What point the formation may start fracking, and we want to know more about the formation. Is the formation strong enough? Is the formation sturdy enough as much as you were expecting? Is the overburden pressure right, what we were thinking? Is the pore pressure right, what we were thinking? So it gives you a lot of information about that particular formation. That is the key benefit of doing an FIT and LOT test. The second direct benefit to a drilling engineer is understanding MASP. MASP stands for, and you will get this when you do any well-controlled course, is maximum allowable, sorry, my poor handwriting, annular surface pressure. Maximum allowable annular surface pressure. So what does it mean? If I'm drilling right here, if I drilled this hole and I lowered a casing till this point, and I performed a shoe test, let's say 5,000 feet, I was using a mud weight of 9 ppg. I'm using API units here. Please pardon me if you're not familiar with it, but this is what I'm familiar with. So I performed an LOT, let's say I performed an LOT test, and I saw the point at which it started deviating was, let's say, 500 psi. Okay, so I have got 3 input points: 5,000 feet vertical depth. This is the TVD. It's very important, no TVD. 9.0 ppg, that's a mud weight at which I conducted my shoe test, and 500 psi is my LOT value, leak off value. What does it tell me? It tells me that the bottom hole pressure right at the shoe when I was conducting the test was 0.052 times 5,000 times 9.0 plus 500. This is the hydrostatic pressure of the mud that was acting on it, and then plus 500. Okay. If I calculate this, should be quick enough. 2 times 5,000 times 9.0, 2340 psi, and let's simply add 500 to it, and 2840 psi. So we have 2840 psi of bottom hole pressure that was acting on this shoe, which tells me that this shoe can withstand a total bottom hole pressure of 2840. What is the equivalent mud weight for that? What does it mean in mud weight? So it means that, oh, I'm sorry, I moved my, okay, there it is. So it means, come on, 2840 divided by 0.052 divided by 5,000, 10.92 ppgs of mud. So this means that my shoe can withstand a total mud weight of 10.92 ppg. Now, this is very important for me, and this 500 psi is very important for me. It tells me that if I continue to drill this coming up section with the same mud weight, 9.0 ppg, my maximum allowable surface pressure is 500 psi. Whenever I'm recording the surface pressure, it should not go above 500 psi in the annulus. And why is it helpful? Because if there is a kick, if there is a gas kick in the well I'm drilling, and the gas bubble is going upwards, the pressure on the surface will rise. And if it goes above 500 psi, I'm going to have a leak off at the shoe, which can lead to, you saw that, fracture breakdown. It can lead to creating a fracture. It can lead to propagating a fracture. You can end up having an internal blowout condition, which is not good. So it is very important for a drilling engineer to know what is your maximum allowable surface pressure. That's point number one. And it's also important for us to understand what is the equivalent mud weight, 10.92. So when I'm drilling and there is a kick coming up and I have to increase my mud weight, I know I cannot go above 10.92. I know that for sure. Even the circulating pressure, the equivalent circulating density, when you're circulating the fluid, the frictional pressure adds onto the bottom hole pressure, it should not go above 10.92. If it goes above 10.92, you will start creating fractures in your shoe. So coming back to the company practices, do we need a shoe test? Well, yeah. And why do we need it? We need it because we want to know fracture and formation knowledge. That's for you, that's for geologists, that's for everyone. And the mask, this is like the personal benefit the drilling engineer is getting so that they can design a much safer well. They can tell the mud engineer and everyone, don't go above this value. Then comes offset data. You can ask the question that, hey, okay, I'm going to design it and I understand that you need frac formation and I need to know by mass. But we have offset data. We have a well that was drilled, like maybe 100 feet away from this well. Why can't we take that FIT LOT values? You can. That's not a problem. You can take those values. But there can be questions raised on it because, nobody is seeing how the formation is behaving down there. You don't know what kind of overburden pressure, what kind of undulations you have in the formation. So it can get a little tricky just blindly following the offset data, but you can copy the offset data. That's not a problem. If you don't have any source of information, go for offset data. That's always allowed. Safety always goes here, mask value. So you need to know what is your maximum allowable annular surface pressure, because that's the safety thing. So the company practice can be, we want to be safe. So as much as possible, do the LOT, do the FIT values. Now there comes time. Do you have time to do that? I know it sounds very silly. I've just told you the importance of doing a shoe test. Why is it so important? Why is it so critical? It's safety. But what about the time? It does include time. It does involve time. It can take you, maybe 1 to 2 hours to perform the shoe test. Maybe depends on how good or how fast the crew is. But in a offshore scenario where a drilling rig is charging $1.5 million per day, time is of the essence. Every hour you are spending thousands and thousands of dollars. So time is of the essence there. Can you do it fast? Can you do it quickly and safely? Both. So time is of the essence. Company practices directly get involved here. And the resources. Do you have the right resources to even conduct this shoe test? Do you have the right resources? Do you have the correct cementing unit? Has it been serviced? I mean, I know you just did the pumping cement with this. You have pumping units, you have rig pump. Do you have the correct resources, correct people, correct knowledge, correct? Why are we doing the shoe test? Do you have the answer to that question? If yes, do it. Always do it. So I hope this helped. I mean, I've tried to intermingle the company practices, why we do it, and what's the purpose. Now, coming to cementing and squeezing the shoe. Now, this was part of the agenda that was in my original, that was told to me. Cementing the shoe The first thing is primary cementation. That's it. You do a primary cementation. Primary cementation means that you went here, you drilled a hole, you lowered a casing, the shoe was right here, and then you cemented. Now, this is primary cementation, pumping into the casing and getting it out in the annulus, having the cement shoe and having a shoe track and all that stuff. That's primary cementation. Now, God forbid, if something happens, if something wrong happens, and you did a shoe test and you figured out, oh, there is something wrong here. There is a fracture created, or maybe there is a channeling happening, or something wrong happened here. And it resulted in bad primary cementation. You will do what is called as a secondary cementation or cement squeezing job. Any cementation which happens apart from primary cementation is secondary cementation. So cement squeezing is secondary cementation. But trust me on this, secondary cementation, squeezing a cement, they don't have a very good success rate. They don't. So your best bet is you do this primary cementation in the best way possible, in having the best quality of cement, having the tests done by the cementing company again and again, the cementing lab again and again. Make sure you have done the right tests, right analysis, right mud weight, because secondary cementation, it may work. You can land a cement plug and then pull up above it, and then you pressurize above it. It may work, it may not work. It's that's always questionable in nature. So the best way to do it is primary cementation. I know a guy who even said, secondary cementation works only in books. It never works in real life. So you have the best way. You want your shoe to behave best, do a good primary cementation, do a good planning on primary cementation. This is contingency. This is always contingency. Don't rely on this. But I'm not saying that people don't do it. People do it very often. Sometimes there's no other option for you to do it. So you will end up doing some secondary cementation. But again, like I said, the success rate might be a little less than that. So this was it. I covered it in, I think, like 30-40 minutes. If you have any other questions, let me know. I'm open up to any questions right now. Are there any questions in the chat? I have not seen the chat. So if you have any question, you can also post in the chat. Put the chat right here.
Mr. Rahman, are you there?
Yeah, I'm here.
I would like to thank you for this great informations. And shall I get into the questions? Do we have some questions? Yeah. My fellow colleagues, you're free to ask questions now in the chat. Ahmed Kamal asks, what is the stinger? Yeah, stinger. Yeah, stinger. I know stinger is a kind of anti-air missile. Never heard of it in oil and gas industry. Stinger string. What is a stinger string?
All right, so that's a good question. I'm really surprised you know it, because it took me a lot of years to first understand what a stinger is. All right.
All right.
So stinger string is something that is used for large hole casings, 20-inch. Usually it stops at 20-inch, but some people may even go for 13/3/8. So it's for large hole casings only. And so like 36-inch or 30-inch or 20-inch casing. So I'm gonna make a big hole here, and you have a casing that goes down. So let's say I drilled a 26-inch hole and I lowered a 20-inch casing. Now, as per the primary cementation rules, what you're going to do is you will be having a float collar right here, and you will pump plugs, a bottom plug and a top plug. and the plug will travel down and it will squeeze the cement and then squeeze it upwards, and this plug kind of like pushes all the cement down. It finally rests on top of the float collar, and you will have cement then filled out here and in the annulus. So it's kind of like a plunger, it pushes it downwards. But what happens with large casing is you have such a huge cement volume and the plugs are so big that sometimes it's not easy to get a good plug wiper job. This plug acts like a wiper, you know, you're wiping water off of your bathroom floor, so you squeeze it. But these plugs are huge. 20 inches is a big size. So what they do, instead of going like this, they use something that's called a stinger string. And what it does is your cement shoe at the bottom is also special in that case. You cannot just use any cement shoe. It has something which is called as a stinger or stab stinger, and you lower a drill pipe, just any regular drill pipe with a stinger at bottom. So this stinger is kind of like a funnel shaped kind of thing like this. And what it does is, let me see if I can do a little fancy thing here. All right, so it's going to go down and fit itself in, stab itself into that small, what I said, the small protrusion this cement shoe already has. So as it goes down, it has rubber seals around it and it seals itself. Now you can pump cement directly in here into this string, into the drill string. Just pump the cement down this drill string. You don't need a wiper. You just keep pumping it, and it's going to come directly into the open hole and up into the annulus. And once you're done with it, you pull on the stinger because it's rubber. You just pull on the stinger and it comes loose. You flush the drill pipe with water so that you don't leave any cement in there, and that's it. So it's a faster job. It's much quicker in nature, and it helps you to, you know, not have cement bursts, some cement left in the casing, and it allows you to do a clean job in such big casing sizes. That's what cement stinger is. I hope that answers the question.
The other question is, what is the most common problem that that is imposed during the casing shoe, about the casing shoe, related to the casing shoe?
It's an interesting question. Man, you guys have tough questions. Okay. What is the most common problem? The most common problem, I would say, is cement shoe washing out. I think that would be the most common problem. So washing out means that you have a hole right here. I mean, let's say you have a casing and you landed the casing and you were drilling another hole right here. So as you start taking the drill bit out in the open hole formation, many times the bit starts wobbling around because it suddenly gets a free rein to, you know, jumble around here and there. So instead of getting a smooth hole like this, you sometimes end up getting an enlarged hole like this at the shoe, something like this. The cement shoe washes out. People what also do sometimes is, if there is a change of, if it is a deep well, there is a change of mud weight order, that you have changed a mud weight. So they do it in stages. They will bring the drill string to the casing shoe, circulate at the casing shoe, change the mud weight, and then go down and then change again. They do it in stages and stuff like that. This unnecessary or extra circulation also can cause washout. So this increases the hole size, which can create ledges in your hole, which can create unnecessary cuttings flowing in, which can, by the end, when you are trying to cement this entire thing, this can take off your volume off of your cement, because a lot of, hey, my voice is not clear.
No, it's quite clear.
Okay, so I
Just the
think
problem with
my
the
friend, I think Mohammed, my friend, I think it could be from your side. I'm sorry about that. So this can lead to cement volume. So I guess, and I'm not able to recall right now any other problem, but this, I guess, would be the most common problem you would see in against the casing shoe, washing out. All right, I see a couple of more questions.
Cool.
In the
other is, is LOT the only way to know the accurate value of MASSP?
Yeah. So it's MAASP. Yeah, I know it's very
Yeah,
confusing.
yeah,
It's
right, right, right,
MAASP, mass. So
right.
it's not SSP, it's MAASP. Anyway, and can we use FI2 to predict the mass? Yes, you can. LOT is not the only way. Let's say you were told that the LOT is expected to come at 14 ppg. Usually you will get this information from offset well data. So you know you're at the rig side, you're testing it, and you know the LOT will come at 14 ppg. And you kept on pumping, and you are now at 14.5 ppg. And it's still a straight line. You did not see any deviation. You and your boss decide, you know what, I'm going to call it off. I don't want to, fracture anything. I don't want to go above what is intended to be. So you call it off. So now this is an FIT. The thing is, you don't know what will happen after 14.5. So why do you want to even risk your mass going above 14.5 ppg? So it's fine to say that my mass is limited to an FIT of 14.5 ppg only. And that is what I'm stating it. I'm not going above that. If somebody comes and says, hey, was that LOT? You can say, no, that was an FIT value, but it's an unknown for me. So I cannot go above that. That's fine. That's totally fine. It's never wrong to be safe. There's a question, I think, what is determinations of pressure in this test? I don't get the question. Can you please?
I think he means what determines the pressure in such test.
Excellent question. What determines the pressure is actually the integrity of. All right, let me draw a better. My drawing is still bad. All right, so I'm going to draw an enlarged part of the casing shoe. So you have your casing shoe here. And you had drilled a little bit of formation. And this is what you had tested. So the pressure actually depends on this part that I've just highlighted. The 14, 15 feet opened up formation and this cement that you have and the formation bond it is making right here. This is what determines the pressure. If it is rock solid, your cement has good bonding with your with your formation, you're going to get a bang on test. You're going to get a good test. You will have good LOT values. Remember, LOT also, what is happening here in the formation, not in the cement. We are not doing anything in the cement. The cement has already been tested to a lot higher compressive strength. So don't think that when you're pressurizing, it's the cement which you are channeling through. No, it's actually the formation that you're trying to find out this weakest link, the topmost formation, when it will leak off. So that's that formation and the bond with the cement that is going to decide how good your LOT is. Okay.
Thank you, Mr. Aman.
Yeah, I think there was a hand raised.
Yeah, I suppose. You just lowered it down.
Dhya, if I'm saying the name right.
Yeah, here it is. Here's unmute. Okay, you're the mic is yours, Mr. Dia.
Okay, thanks, boss. Thank you very much, Aman, for the valuable information that you share with us in your lecture. So just a question that I have, could you please clarify the difference between the extended leak-off test and the normal leak-off test, XLOT versus LOT? Thanks.
That's the part where I'll be very honest, I even am not very good at. Extended LOT tests are usually when you are trying to push the boundary that you saw here on the LOT, where you're trying to see till what point of time you can actually move towards formation breakdown pressure. So it's not that you are leaching towards the formation breakdown actually, but some formations behave in a way that there may be a part where you can get a leak off, and then you can even extend it beyond that your certain your current expectations where your fraction formation breakdown is. So that's where extended LOT comes in, where you are trying not just looking at the first point of departure from the straight line. You're also looking at parts where it may even have another breakdown or another opening up of the fracture, where that will mark as your extended LOT. I'll be very honest. I myself, and like in my personal experience, I don't have much experience working on extended LOTs. They are conducted at very controlled rate. They are conducted at very controlled locations. You cannot just go and say, okay, I'm going to do extended LOTs from now on. No, you have to consult with the geologist if it is even okay to conduct an extended LOT, because if you don't do it right, you can end up breaking the formations completely, and that would not be good for you.
Okay.
So yeah, sorry, I don't have a perfect answer for you, but it's a limited thing that you do. Yeah.
Okay, but so I mean, do you have any idea whether the information that or the data that I'll go to from the extended LOT will be more accurate, or how could be useful for our work, if you have any information?
So from the drilling point of view, or from the general petroleum engineering point of view?
Okay, in both views.
So from drilling point of view, I would say if we did an extended LOT, it helps me understand the point that the first leak off point, whichever I have, whenever I had the first leak off, that is my mass. I would not go above that. But if I went on an extended, I know that, okay, there is a flexibility in the formation. There is a flexibility that I can go even above that. So if there is a worst case scenario that comes to me that I have to extend the pressure, annular surface pressure, above the LOT value, I know I can go above that because I have already done an extended LOT test. So that's point number one for it. That's from the drilling point of view. From the geophysical or geology point of view, I can say this again is for formation, understanding the flexibility or the integration of that formation. There are correlations available that allow you to understand if you have an LOT value of whatever 500 psi, whatever you have in this chart. How can you extrapolate what is the value, what will be the value for FBP or the FPP? There are empirical correlations available. There are logarithmic correlations available based on the petrophysical information. So if you did an extended LOT test, there are again correlations available empirical for that particular type of formation, which help you in understanding how this formation will behave and when will it fracture and how can I fracture this formation if I have to for better oil production.
Okay, thank you very much.
Yeah.
Any further questions? Right. Mr. Aman, very glad to have you here today with us, and very thankful also. And just thank you for being with us here today and accepting our invitation.
Yeah, of course, it was my pleasure. This was really nice. By the way, I mean, I can share my LinkedIn with all of you. Please go ahead. You have any questions, you can contact me through LinkedIn, and we can have more conversations over there. I would love to stay in touch with all of you.
You heard the man. Go attack his account. That's an order.
My pleasure.
Thank you. Thank you. Very, very thankful. Yeah.
Oh, I think is that a question? I don't know. I think it's
no, it's
written.
not a question. He just
Okay.
pointed about some fact.
Okay. All right.
Yeah.
Thank you. Yeah. Sorry, I'm not smart enough to read your language. I'm really sorry about that.
It's not about being smart.
I can't read this, so I'm really sorry about that.
Yeah.
Okay. So guys, if you have any other questions, let me know. You can ping me through LinkedIn, and I would be more than happy to communicate with all of you. That's not a problem for me. And good luck with whatever you guys are doing. Stay in touch.
Thank you, Mr. Aman. Thank you. Very thankful.
All right.
You're
Take
welcome.
Bye bye.
You're welcome.
Bye bye.
Welcome. For the attendances, my fellow students, workers, any of the attendances, you are encouraged to fill out the attendance form. The link is just in the chat. You can click on it and fill the attendance form. السادة الحضور المستمعين، يرجى ملء استمارة الحضور اللي موجودة بالشات. شكرا لكم.